Hello everyone, in this video we are going to write down the Lewis structure of chlorine trifluoride, which is a interhalogen compound. To determine the Lewis structure, first we need to count the total number of valence electrons in the molecule. Atomic number of chlorine is 17 and therefore we have 17 electrons in the element. So the electronic configuration is neon, that has 10 electrons, and then 3s2 3p 5, that accounts for 17 electrons in total, but we have 7 valence electrons and the neon is the core, and then atomic number of fluorine is 9, therefore the electronic configuration is helium, the 1s2 core, and then 2s2 2p 5. Here also we have 7 valence electrons, but we have 3 fluorine atoms. Therefore, 7 times 3, that is equal to 21. Here 7 times 1, that is equal to 7. So, in total we have 28 valence electrons in ClF3. We know that fluorine is more electronegative than chlorine. Therefore, we are placing chlorine at the center and then placing the fluorine atoms around it. Let us put a bond pair between chlorine and fluorine. So, we have 3 bond pairs. In total, we have 28 valence electrons. So, therefore, let us put 3 lone pairs each around fluorine so that we can satisfy the octet configuration. So, now we have utilized 18 plus 6, 24 electrons, but we still have 4 valence electrons remaining. So, therefore, we are going to place 2 lone pairs on top of chlorine. Now, if we check for the octet configuration, fluorine atom obeys the octet, but chlorine atom does not obey. However, this is okay because chlorine atom belongs to period 3 and therefore, it can go for extended octet configuration. So, since chlorine atom has access to d orbitals, having 10 electrons around chlorine is completely okay. Let us see whether this is the best Lewis structure or not by calculating the formal charges. If we get formal charges as 0 for every atom, then we can say that this is the best Lewis structure for ClF3. Let us determine the formal charge for each atom in ClF3. Formal charge is equal to total number of valence electrons in the atom minus total number of lone pairs of electrons minus total number of bond pairs of electrons divided by 2. So, therefore, for chlorine this is equal to, we have 7 valence electrons minus we have 2 lone pairs, therefore 4 here, minus we have 3 bond pairs, therefore 6 by 2. So, this is equal to 3 minus 3 and that is equal to 0. So, therefore, the formal charge of chlorine is equal to 0. So, for each fluorine atom, the number of valence electrons is equal to 7 and then we have 3 lone pairs. So, therefore, 7 minus 6 minus we have 1 bond pair, therefore 2 by 2. So, 7 minus 6 1 minus 2 by 2 is also 1. So, 1 minus 1 and this is equal to 0. So, therefore, for each fluorine atom also we got the formal charge as 0 and therefore, we can say that this is the best Lewis structure for chlorine trifluoride.